Everybody, I'm Toni Cameron from Metamorphosis Teaching Learning Communities. I'm here with my colleagues and we're going to explore another interactive game.
Hi, I'm Daniel Scher.
Hi, I'm Ellen McCrum.
And hey there, I'm Stephanie Slabic. Thanks for joining us once again for our interactive learning series, which focuses on developing students' mathematical reasoning and strategic thinking. So the games that we've been sharing may seem pretty straightforward and easy, but remember there's a lot of rich mathematical thinking that can be developed using our games. And so remember to click the link that has the analysis to this game to help you work with your child.
We believe that play is at the heart of learning, and games are a playful way of engaging in learning. We also think that not all games are equal. Some games are not actually games because they're not fun. We use Dan Finkel's What Makes a Good Game to help us think about how to analyze games. And he uses three main points about games. First of all, there should be choice. There should be some options for playing the game, and that choice actually engages the learner. Math should be the engine of the game. This is point number 2. The point of the game isn't something else. The point of the game is developing mathematical reasoning, thinking, strategies, problem solving. Point number 3, the game should be simple and easy to learn. You don't want it so convoluted that students get bored or frightened by what they're trying to do. So those are our 3 top points. The main point is games should be fun and they should be about learning mathematics.
So let's learn how to play the Bullseye game. On this page, there are 2 bullseyes, but I'm going to focus just on this one for now. It says to drag numbers into the circle to make a product of 20. And these are the numbers I can use: 2, 4, 5, and 10. Okay, so what do I know about numbers that would make a product of 20? Well, I know that if I have 4 groups of 5, then that makes 20. So if I think about that in terms of multiplication, I should be able to drag a 4 and a 5 and say that 4 times 5 is 20, since it's taking the product of the numbers that I drag into this bullseye circle. So let's check. I'll press the check button, and oh, I got it. Great. Now if I want to play again, I can just press the reset button and try to find different numbers whose product is 20.
All right, well, I know 10 and 10 make 20. So 20, let's check. Huh, I thought that would work.
Interesting, Ellen. I see you using what you know about addition, and you know 10 and 10 is 20. Maybe start thinking about it in terms of how many groups of 10 do you need?
1, 2, I have 2 groups of 10. Okay, let me try again. So 2 groups of 10. All right, let's check. I got it.
All right, here we go. It's my turn. I know that 4 times 5 is 20. So I'm going to pull over 4 and a 5, and I'm going to check. I got it.
So Stephanie, that seemed pretty easy for you because you used a basic fact. 4 times 5 is 20. You used 2 factors to make 20. I'm wondering if you could make the product of 20 with 3 factors.
Ooh, that feels challenging, but I can try. Let me reset. Let's see, 2 times 4 times 5. Would that work? Check. Oh no, try again. Okay. I'm not sure where I should go next.
So let's go back to your original, the original way you made 20
Mm-hmm.
was 4 times 5. So if you reset it
Mm-hmm.
and you use your original factors, which are 4 times 5, is there a way of thinking about deconstructing one of those factors that would help you make 20 with 3 factors?
Yeah, that's a great idea, Tony. I was thinking that 4, I could actually think about 4 as 2 times 2. So let's try that. If I think about 4 as 2 times 2, it's like a factor of 4, and then I can multiply that times 5, and that should work. Let's try it. Yes, I got it.
You might have noticed that this game board is set up in a way where you're comparing two quantities, 20 and 100. There's a specific relationship between 20 and 100. That is, 100 is 5 times greater than 20, or 20 is a fifth of 100. These are important relationships that students need to build. So for example, if they are fluent with the factors that make 20, how could they use that knowledge to help them build 100? So let's look at one strategy which a child might easily say, I know 10 times 10 is 100. Now, what if I wanted to make 100 with 3 factors? Well, I would have to deconstruct one of those factors into 2 quantities that when multiplied together would make 10, and 2 times 5 is 10. So here I've created another solution by thinking about 10 as 2 times 5 and multiplying 2 times 5 times 10. These are important mathematical big ideas that can easily come up in this game. We encourage you to have your child record their solutions from game number 1, and then to think about how could the solutions I have help me think about ways to make the product of 100.
So we've just had the opportunity to look at solving a game where the product of the numbers was 20, and then a related game where the product of the numbers was 100, and the relationship between solving these two. We wanted to give students an opportunity to see a similar relationship, so we built a second page of this game. In the lower right-hand corner of the game, you'll see that there's a page navigation control, and if I press the right arrow, it moves us to a second paired set of problems. Here, the product on the top is 24, and on the bottom, we have a product of 48. And as before, students can think about the relationship between those numbers that make a product of 24 and those that make a product of 48.
Thanks for joining us. We love having you. Look forward to creating more games and having you join us and playing them. We also would love to get feedback, so be sure to check out our website and write to us if you have any questions or comments. We love to improve what it is we're doing, and we look forward to hearing from you.